I would like to welcome you all to the talk. We are going to do a beginner level talk on Terraform, what it can do for you and your company. My name is Bruno Bandeira de Azevedo. I am a full stack software engineer and DevOps in Order.this, which is a company from the Auto Group. We're focused on creating IoT, an open IoT platform to integrate e-commerce and IoT solutions. So we're going to start with a brief cloud history. I don't know if you guys have been deploying cloud since, but we've been doing this since 2008 when it first launched. And do you remember when you deployed your first VM on a cloud provider? Let's say it's 2008. The year Amazon Elastic Cloud Compute dropped the beta label and went into full production, and your company is eager to start using it. How many knobs and pulls, options and checkboxes you had to fill to get your first VM up? After you had to configure it. It's your first VM on a cloud provider, so you're concerned with costs, of course. So you take a long time to go through the options to set up the most cost-effective VM for your workload. So you choose to leave the VM running afterwards. After all, the costs aren't that high, you have the free tier, and it's a wild, wild west of the cloud. But then you start a new VM for a different application. Configure it just slightly different, and this behavior repeats itself. Soon you have a plethora of cloud infrastructure that was configured by different team members at different points, where a specific set of best practices was set in place, which hopefully were followed. But you can't be entirely sure of what's inside those VMs and what kind of configuration and setup it has. For some companies that I worked for, this was a standard, either because we failed to do our due diligence or because we had deadlines and clicking through menus was a lot faster than actually doing it in a more reproducible way. This is what the EC2 console was in 2008. It didn't have all that, it wasn't that many options, but if you can see the process repeating itself, and then you have this. A bunch of EC2 instances with God knows which kind of configuration inside them. So some were properly deployed, some were not. And now you don't know anymore what's inside every one of them. The next rational step to try to bring some order to this would be to automate it with API calls and CLIs using scripts. But that still needs to take into account the order of provisioning. Maintaining those scripts and the infrastructure configuration inside those scripts can be a bit of a pain. So this is still a mess, and as we as engineers can do better. So this mess has sparked some initiatives that aim to bring some order into this chaos. The first one of them was CloudFormation, starting in 2011. Azure ARM templates came right after in 2014, and Google started deployment management templates in 2015. They are all fairly different templating techniques with different advantages, disadvantages, and quirks. So as engineers responsible for cloud infrastructure, we want to make sure that, that the resources we provision are peer-reviewed and can be are properly documented. So making sure we can commit our infrastructure to a repository is very important. So we need something better. We need something that's agnostic, something that doesn't take into account a specific cloud provider. We need something that can be open source, so we can modify it as we see fit, and can be easily extensible, and preferably that has a strong community behind it. So it brings us to the topic of this talk, Terraform. Why Terraform? What's so special about it? Terraform is a declarative infrastructure as a code tool. That means that instead of stating the resource that we want to create just now, we declare the state that we want our infrastructure to be in when we apply those changes. It's an open source, extensible, and with a strong community behind it. And getting a complex, sorry, getting a complex architecture is as easy as doing a Terraform apply, and bringing it down is as easy as doing a Terraform destroy. So why choose it? It has a big company behind it, with a strong track record behind it, HashiCorp. And the project has a really strong community with over 1,200 contributors, over 100 releases, and it currently supports over 90 providers over an array of topics. So databases, cloud providers, services, and you can have a small group of Terraform experts inside your organization that generates these templates, and then a group of consumers that can just modify them slightly using variables. So it gives you freedom of deployment and sets standards for your architecture pieces using the best experts that you have in your organizations. We're going to just do a small demo. This is going to be recorded, by the way. Terraform uses what they call HCL. This is a declarative language, and this is a declarative statement. We have an AWS instance here as a resource that's going to be created with the name example. And this sets what I would like. That's the provider, which in our case is Amazon Web Services. And I got just a small region in there just to help, but it could draw that from our environment. And then in the case of the key and the secret, it's also going to pull that from the environment. And we're going to see just how easy it is to just apply that. Let me just... So first we're going to do an init just to pull the providers. And in this case, just AWS. Then we're going to go to the planning stage. On the planning stage, we can actually see what kind of resources are going to be created or modified or even destroyed. We see that we're going to create the instance example with some predefined and some computed attributes. These are going to be shown next, and we're just going to apply that. It's being fast forward, so we don't have to wait all that long, because sometimes to do all the API calls can take a bit long. So yep, it's gonna go through all of our files and it's deployed. We can see what kind of attributes we have on our resources right now doing Terraform show. We can even see the public IP, private IPs, and every single configuration for the VM. And now we're just gonna destroy it since it's fine. And again, this is really quick. And it takes like 50 seconds to destroy it, and we can start brand new modifying it. Now that's all nice, but we need to focus on the bottom line. How can my company benefit from it? How can we actually take advantage of it? By controlling your cloud environment, you get to restrict what kinds of resources and infrastructure gets deployed. By restricting those things, we can adhere to enterprise restrictions and guidelines and only use previously approved infrastructure. And this brings peace of mind for the company heads, because you get to know that whatever your cloud provider, cloud experts are providing for your company is previously approved by them and by you. And it brings peace of mind for the developers, because they know that the infrastructure pieces that they're using are previously regulated. So we can adhere to best practices, free up time from the cloud expert architects, be a single source of truth for those best practices, and centralize our knowledge. The developers gain the freedom they seek, and they can alter the resources using variables, so they gain also the flexibility, and we are sure that we can follow security and best practices. By standardizing everything, we know that we make maintenance for our infrastructure easier. If you're building something to be the basic building blocks of your infrastructure, the concerns with security and best practices should be first and foremost. So by controlling your infrastructure and and defining your standards, you are more able to estimate the costs of deploying a new service before they are even deployed. So you can by doing everything inside infrastructure as a code, you also can commit your infrastructure, have it reviewed, so that no details are left unchecked. You know who did your architectural decisions, when did they do that, and what was it. So you have a trail of commits so that you can actually specify and review them as you see fit. But going back a little to what Terraform represents for infrastructure as a code in general, Terraform has been the rising industry standard for infrastructure as a code, with over 90 providers. That goes between cloud services, databases, and more. It's gaining a widespread mainstream adoption now, and it's being used by over 300 companies from Uber, 9gag, InVision, Twitch, Circle CI, and more. So, but what really excites me about Terraform is the iteration possibilities. This is where Terraform really shines. With Terraform Plan, you can always get a view of your changes, and by iterating, it lets you do infrastructure what you kind of do with software. So, and with per second billing on most cloud providers now, you can experiment on your infrastructure as much as you like with little to no consequence. So this rapid iteration process favors experimentation, and by experimenting often and a lot, you can innovate more often. Now, going back to that demo, we're going to do we're going to expand that a little bit. We're going to create an EBS volume. We're going to extract those attributes, a couple of them, to variables, so that we can extract that to what they call a TFVARS file, and we can give that to our developers so that they can configure their own resources. And we're going to also do a volume attachment. And on the first pass, I'm going to leave the resources, this resource, the external IP, commented, so that we can see how Terraform just shows you the diff between your state and what you actually want to change. And the output is what can serve as an input to other modules. So you can actually build from this IP to, for example, build a CloudFront distribution. So let's just create that. Again, we're going to do the init. You don't always have to do this, but since this is a new folder with different infrastructure, we just did it. On the plan stage, you can see that we don't have the IP now, and all the attributes are here. But so we're going to apply this one. This is the first pass, and then we're going to uncomment that the IP and the output so that we can see what happens. Just real quick. Yep, I confirm it, and it gets deployed. So now we're going to uncomment that and just plan and apply again. It's always good for you to plan first, because for you to actually review what you're going to do. So you can see here that the Elastic IP is going to get created and attached to the previously created instance. So we just apply it, and it's done. This is just a diff from the previous state. And now we're going to destroy everything. This sort of rapid iteration on your infrastructure enables you to learn quite quickly what works and what doesn't, and build on top of that. So we can just destroy everything again and go from that. So now talking about some features of Terraform. Being able to modify your software as you see fit is very important, and Terraform is open source under MPL 2.0. You can modify it as much as you want. You can create providers that you don't have, and centralize your resources and services around it. By standardizing your basic resources like VMs, you can separate them in what Terraform calls modules. With those modules, you can abstract blocks of your basic infrastructure and create reusable pieces that can be configurable and enable more powerful configurations. Just to test some of those modules out, let's get back to that quick demo. Here we extracted those configurations that we previously used into modules, but this has a bit of a twist. Terraform has a bit of a quirky way of doing an if statement. We can't outright remove a resource in case of an else, at least not now. But we can set the resource count to 0. And here we see this variable being created, the create IP, that gets interpolated into the Elastic IP resource section. So Terraform interprets false as being 0 and true as being 1. So from the parent description of this resource, we can declare the create IP variable as being either false to not create it or true as to create it. So we do this to get our front end to have an Elastic IP, but our backend to be without the public IP. So just doing that again. And again, in this case, we need to actually do the init to pull the modules, because those are the building pieces. And then we do the planning stage again, where we see that we won't have the Elastic public IP. We just have it for the front end, but we don't have it for the back end, which is kind of what we wanted. So these kind of configuration pieces that you can add and modify and provide to your operators is really the key to Terraform. You can do this as much as you'd like, and you can get pretty much everything you need from this sort of iteration. And again, destroying everything. No, this is creating, sorry. And we get the CloudFront IP from the output. The CloudFront, no, sorry, the front-end IP from the output. And we can use that to build on top different modules. So now we're going to destroy everything, and this sort of plan, create, destroy is part of what makes this thing so nice and so fun for cloud architects. You can iterate on it several times before actually settling on an infrastructure. So those modules, we can grab them also. We can create them or build them or get them from a module registry. The main one is maintained by HashiCorp. They can be as little as a VPC or as big as a complete cluster development deployment. There are other module registries that you can use, but this is the main one. And another important feature are the providers themselves. This is the ones that HashiCorp actually gives you. So we have AWS, Google Cloud, Alibaba, Oracle, and GitHub. But another important feature are the providers themselves. The providers allow you to wrap API calls to resources. So you can implement your own. And they can be as little from issuing HTTP requests on your behalf and using the body to actually using a full-fledged Google Cloud provider. So there are several unofficial provider implementations on GitHub that you can draw from, but they can vary in quality. And you can implement your own. We really encourage you to do so. Now, regarding configuration, Terraform has what they call provisioners. They are scripts or commands that can be run inside the resources. And this can also be chef cookbooks, and they are part of the life cycle of resource creation. So they can be applied on apply, they can be applied on destroy. So they can bootstrap your newly created infrastructure, or they can do the cleanup for you. That's part of the configuration management. So okay, that's all fine, but how does Terraform know what is currently in my infrastructure? Terraform has the concept of state. When you apply from Terraform, your infrastructure is put in a certain state. Terraform records that state and on what it calls a state file, and checks for changes against that file on anything that you modify. Now, if I run Terraform on my laptop, the changes will be local and won't really have access to the current, and my teammates won't really have access to the current infrastructure state. But we have a way to fix that. We can do what we do, remote state management. This means having your state stored somewhere else. One of the most popular options are S3 buckets, Google Cloud Storage buckets, or console. These enable collaboration with your teammates on your deployments, so you know what gets deployed and what is up to date with the current state of your infrastructure. Some backends also enable remote state locks, which lock your infrastructure changes, so you don't get the situation where you're doing a change and then your teammates come in and also do a change, and you don't know exactly in which state your infrastructure is currently in. So one of the tools that help you do this, there's Terraform Enterprise that enables centralized state storage and configuration. It has a really nice UI that you can use to do your infrastructure changes. But there's also an open source option called Atlantis. It's an open source collaboration tool. You install it in your own on-premises, and it connects to GitHub. So you can do the Terraform plan and apply or destroy directly in a PR request. So it's a great option for teams, and it's open source. So you can get a little bit of what makes enterprise really good into your own infrastructure. The not so good part. Terraform is really nice, but it has some quirks that you're probably going to run into. One of them is debug. Terraform gives you a description of the error of what happened when you're deploying, but that description can be sometimes a bit misleading or outright wrong. So it's hard to filter, and Terraform doesn't really help you much with that. So when you're starting up and starting to test things out, it can be a bit frustrating. And of course, not all providers are written equally. So if you get some low quality, not so polished provider inside your infrastructure, you can run into some issues. So unless you can, and also Terraform doesn't allow step-through execution. So unless you segment your infrastructure in different kinds of folder and state and is able to build it in small pieces, you're going to get everything at once. It's going to build everything you have on that state. And that can be a bit frustrating to debug in case of issues. Also, we have API changes. Everything in Terraform is changing rapidly. So Terraform itself is under high development, and so are their APIs, as well as the provider APIs for everything that you get. So cloud for AWS, Google Cloud. And since that's changing along with Terraform and along with the cloud provider APIs themselves, that can lead to some really weird bugs that can creep up. You can version your provider to minimize those, but they're gonna happen. Another thing that you can have, Terraform state file is nothing more than a text file. So it holds your entire infrastructure state on that segment. So you can segment it in several different state files and apply them accordingly. But if you have just one text file for your entire infrastructure, if you lose that, Terraform is going to think that nothing exists and it's going to try to recreate them. So direct manipulation on that text file is highly discouraged. And any corruptions that you might have can lead to errors and an unstable infrastructure state. So don't manipulate this directly, and use remote states, because they can really help. Especially like an S3 bucket with versioning. That can help also a lot. One of the nice and not so nice things about Terraform is that it's non-opinionated. So you can organize your infrastructure as well as you'd like, or as little as you'd like. So you can have everything in one file, and then even the different environments in one file, or you can segment that thing. And structuring your file is really important. So if you don't do that, you can create a bit of a mess in your infrastructure. And afterwards, you can even introduce human error to the equation, because if someone does a destroy in a resource that they think is a staging environment, and then it's not, yeah, they can lead to a lot of problems. So, but using modules and using remote state files and segmenting those states, you can kind of mitigate those problems. So that kind of wraps up for now. So just a closing. For Terraform, I really encourage you guys to just go out and experiment. You can do a lot in quick time. You can be compliant to standards. You can enforce security. You can free your developers and reduce your costs. So HashiCorp has a really nice documentation, and there are some books out there that can also help you with the process. And I encourage you to just go out and experiment. Terraform enables that, and experiment on your private environment. Experiment on your company, and it can really help you deploy infrastructure in a safer way and more reliable. So that's it. Thank you all for being here, and that's it. And questions, anyone? Yes?
You talked about state corruption.
Mm-hmm.
So I imagine if you have something like a pipeline or something, which exports a state file all the time, that's fine. But what if somebody comes in, changes something in the console, then there are some resources which Terraform doesn't know about, right?
Mm-hmm.
So how do you generally deal with these situations?
When you get that kind of situation, you can import those resources into the state file manually. So there's no magic that Terraform is going to discover those services for you. You're going to have to manually import them. So you can even use Terraform in your existing infrastructure without any sort of problems, because they're going to tag each of the resources.
And when you say importing, is
There's a command for that.
Okay, cool.
It's just in the CLI.
Since it's a text file?
Yeah, you can even modify it using the CLI, like even removing resources from your state, which doesn't remove them from the infrastructure themselves, just from the state. So you can manipulate in that way, but you can also go in by hand and modify it, which is, again, not encouraged.
Thank you.
Okay. Yep.
I was just wondering, what are your thoughts about Terraform combination with Kubernetes?
That's what we use, actually. Terraform's integration with Kubernetes is not that good. You can deploy some Helm charts, but the configuration is a bit really basic. There was a problem with the Helm provider that didn't quite fit with GKE, so you couldn't deploy it all at once, like your Kubernetes with all of the applications in one go. So right now we're doing it separately because of those problems, but it seems that there's a PR for it that it's supposed to be merged like this week or the next, that might enable you to do everything at once. But right now you have to like separate between Helm files and Kubernetes and Terraform. Okay. Yep.
So I have two questions. First one is, how do you deal with desired state management? So if you create infrastructure with Terraform and you mess up manually, how do you, does Terraform fix it?
No, not automatically. You have to go by hand and import all of those resources into a new state file. What I would actually recommend, if it's a small infrastructure, try to do it manually, one-on-one, because otherwise you might get a big mess.
So this is my biggest grudge or concern with the cloud formation.
Mm-hmm.
My second question is a bit of comparison. So we are heavily invested in cloud formation. We provision all of the infrastructure with cloud formation, and we deploy with an in-house tool. I don't see any incentive to move towards Terraform. Why I say this, because we have no plans to move to any other cloud provider.
Yeah.
So what is, why do, if I have to try, I like Terraform by the way,
Mm-hmm.
I have to convince my management, what is my reason?
Well, I guess, well, if you're that heavily invested into one provider and you already have everything as a cloud formation, I honestly wouldn't recommend you to do like a whole change to Terraform, because it can be, you can take quite a while, and maybe the results aren't exactly what you're expecting. So in that case, I wouldn't recommend you to do that. If you want to start with small pieces, but the good thing about Terraform is that it enables you to change some of the resources around. So, but honestly, I just wouldn't go that way if I was you. Yep.
Let's say that I want to use Terraform for migration. So I'm a certain cloud provider. I want to use
Not that I know of, and that process could be a bit dangerous, so I wouldn't recommend it. But not that I know of, so it would have to be manually. So for a big infrastructure, it's not recommended. Unless you don't even have any sort of infrastructure as a code. Then I would guess that for compliance reasons, it would be nice to actually get it done, but no. Anyone else? Okay. So thank you guys for your time.